Good day everyone. So now we are going to discuss about how to program the timer with match register. So we'll directly get into the program. So this is the program that is concerned with the timer using match register. Here what I'm going to fix is like I'll be fixing one of the port pin connected to the match register, so it will uh, go for toggling whenever the match occurs between the timer's match register and the T0 TC. So here the program will go step by step. So the first line, area space some label comma code comma space read only. So this we have seen already why we are giving this one. So we are defining the area with the label, and this is going to be a code, and this is going to be stored in a read only memory. Then I am initializing this IO0 dir, IO0 set, and IO0 clear. So actually for this particular program, this IO0 dir, IO0 set, and IO0 clear is not required. Actually this is required for the program which doesn't uses the match register, so I'll remove that. So coming to this the next register, T0C TCR, this is the timer control register, wherein you will be specifying the mode of operation of the timer using this register. So I am using this EQU assembler directive, so that whenever I am using this label inside the program, it will be replaced with the memory address 0x E0004070. Then T0 PR is timer 0 prescale register, prescaler register. So it has its own memory address that I am equating it using this EQU assembler directive. And this T0 TCR, this is the control register to reset the timer or start the timer. So both operations will be using this one. And T0 TC is the timer counter. Timer counter. So this happens to be the register which counts whenever the T0 PR content is being matched with T0 PC. T0 PC is T0 prescale counter. So T0 TC is T0 timer counter, and T0 MCR. So MCR is match control register. So this match control register I am equating it to 0xe004014. This is its memory address. And T0 MR0. MR0 is match register. So here I'll be putting the content inside the match register. So whenever the value of T0 TZ matches with the T0 MR0, toggling should occur. That is the algorithm of this particular program. And T0 EMR is timer 0 external match register. So it has its own unique memory address that I am equating over here. Then Pincel 0. So Pincel 0 happens to be the Pincel register special function register, and for that we are having the memory address 0xe0002c000. So coming to the program, LDR R0 comma equal to Pincel 0. So here the Pincel 0's memory address E0002C000 is stored inside R0 register. Then I am moving R1 with the value 0x80, and that is stored inside the Pincel 0 register. So this 80 is significant. Like you can see, the 8th bit is the 7th bit is made high, so that in the port pin P0.3 is connected with the match signal. So in case if you want to look upon the Pincel register, once let us check the Pincel register's content. Okay, this is the Pincel 0 register, you can see. So here I am speaking about the match 0. So match 0 is connected to P0.3. You can see 0 1 2 3. So this is the first digit, and this is the second digit. So the second digit I am making it as 80. So 8 is represented by this one, so match 0.0. So I am making port pin P0.3 as connected to match 0.0. So for that condition I am making it as connected to the match register. So that is the reason pin cell 0 has been given with the value 0x80. So you can see, in case if you want to see it in terms of binaries, you can see it in this way. The 7th bit is made high, so we are getting 8. So this is 7th and 6th bit, as you have seen in the PPT. You can see 7th and 6th bit 1 and 0, so P0.3 will be connected to match 0.0 in the pin cell 0 register. Then coming to this T0C TCR. So this is the mode register timer. In case if you want to make it to counter mode, then you will be putting some value. If you want to make it as a timer mode, you will be invariably putting it as 0x0, so it is acting in the timer mode. So T0C TCR is moved to the value of 0x0. So STR R1 comma R0. So to T0C TCR, 0 is moved so that it behaves as a timer mode. Your timer 0 behaves as a timer in the timer mode. Then T0 PR. So we have already seen the calculation for the prescaler register. So the same calculation we are using it over here. I am calculating the value of a prescaler register for 1 millisecond. That happens to be BB7. So BB7 has been moved into R1, and R0 is moved with the T0 PR's address. So STR R1 comma R0. So this BB7 moves into T0 PR register. Then T0 MCR. MCR is match control register. So coming to this match control register, let us check the match control register. So you can see this is the match control register, in which each and every there are basically 4 match registers available: MR0, MR1, MR2 and MR3. So in this case we are going to use MR0. So we can make the MR0 to behave in such a way that if 1 is specified in the 0th bit, it will generate an interrupt. If this particular bit is activated, reset will happen. If this particular bit, the second bit, that is the it is having the value of 4, if it is being set, then the match register will stop. The timer will be stopped. TC and PC will be stopped, and TC R will be reset. So in this case, what we are going to do is we'll be activating this one so that reset will occur. So reset means again it will start from the 0 again. So the same thing can be specified in MR1 and MR2 and MR3 also. So this is the content of T0 MCR. So in case if you want to see it in bitwise fashion, we can see it in this using this structure. You can see here this MR0 is been provided with I in the sense it is interrupt, R in the sense it is reset, and S in the sense stop. So same with these things. So the remaining bits are all reserved, you can see. So we are giving a value 002 into T0 MCR register. So T0 MCR is moved with the value of 2. Then the next is T0 EMR. Coming to T0 EMR, this is the EMR register. This is external match register. So first I'll have to activate the external match, which external match I want to be active. So here external match 0 I want to make it active. So this is 0th bit, I'll be making it high, and consecutively each and every match register will have a control in these bits. So here 4 and 5th, 6th and 7th, 9th and 8th, 11th and 10th are connected to the match register 0, 1, 2 and 3 respectively. So each and every bit will have a control structure like this. If I am making it as 0, 0, it will not do anything. 0, 1, it will clear the corresponding external match bit, and if it is 1, 0, set the corresponding external match bit, and if it is double 1, then the corresponding match bit will be toggled in the sense, previously if it is 0, now it will become 1. Previously if it is 1, now it will become 0. So we'll be making it to toggle. So this is the external match registers structure. If you want to see it in the pattern of a bit, we can see it in this way. You can see T0 EMR has the bit pattern like this. So here EM0, EM1, EM2, EM3. I mean here I have made like EM0 as 1, so I am activating this external match 0, and external match 0, what should happen, EMC0 I am making it as 1 1, so that it will toggle. So if I am putting 1 1, it is having 2 and 1, you can see. So combine to get 3 0 0 3 1. I'll be moving into T0 EMR register. So 0x 3 1 is being moved into EMR register. Then coming to T0 TCR, I am moving a value 2, so that the timer is reset, timer counter is reset. So that can see through this one T0 TCR. I mean the second bit, if I am making it as a 2, then the counter is reset, and when I am making it as 1, I mean the counter will start. So T0 TCR, so the counter is starting. So this program comes and stays over here, and it doesn't do anything after that. So your timer will take care of toggling the output. So already we are connecting the timer's match register towards the port pin, so there is no other checking involved inside the program. You don't have to check anything inside the program. All the checking will be done by the match registers by itself. So let us check how the things are happening. So now I am putting the port 0.3 over here, because port 0.3 is the port pin that is connected with the match register. So I have connected, and here T0 MR0 I have moved a value of 4. So this I have forgot to tell you. T0 MR0 is match register 0, wherein you'll have to move a value which is concerned with if you want a 5 millisecond delay, you'll need to move a value of 4. If you need a 10 millisecond, it should be 9. So now since I have moved T0 MR0 with 4, the delay will be for 5 millisecond. Let me run the program. So now I am getting the output over here. Let me check the timer also. Timer 0. So you can see now here the MCR is moved with 2 and MR0 is moved with 4. So whenever this TZ is reaching the value 4, it is getting resetted, and you can see this reset on MR0 is happening. Each and every match registers can be connected with individual operations as such. So here, since it has been connected with toggle and the external match register is connected with the port pin P0.3, I am taking the port pin at P0.3. So using this panel you can understand what is happening as such. So now in case if you want to check the time delay, we can check it like this. So you can see exactly the value that is obtained is 5 millisecond. So this is for just programming the timer match register. Okay, so we have discussed how to get the output using the simulation. So in case when we want to dump it into the board, so you need to go into this options for target, click this output and click this create X file. This is the name of the executable file that will be created, and that X file you need to dump it into the ARM processor. And after dumping, we need to know from where we have to take the output. So for that we have to see the schematics. So this is the blue board schematics. So you can see, we are supposed to take the output from P0.3. So P0.3, you can see that is connected with P0 underscore A3. So we need to check where is this P0 underscore A3 in this J1 J2 connections. So here this is the 10th pin, that is P0 underscore A3, and 9th is the ground. So when we after dumping the code, so we need to take the output from the 10th. The 10th will be connected to the positive of the probe and 9th to the negative of the probe. So we'll get the same output whatever we have got from the simulation. So this is for the timer with match register. And now we'll check with the two match registers. So in this case only one MR0 we have used. So now let us check with the two MR0s. So this is the timer with the two match register. So in this case also I can remove these registers, that is not required. So the same thing, T0C TCR for the mode representation, T0PR prescale register, T0 TCR for resetting and starting the timer, T0 TC is the timer counter, T0 MCR match control register, and MR0 and MR1 I am using in this case. So this you will have to take a note of. And T0 EMR external match register, so pin cell 0. So all these I have initialized so that inside the program I will be using these labels. So LDR R0 comma equal to pin cell 0. So in this case I am moving a content 880. So the 8 is making the 7th and 11th bit of pin cell 0 register to go high, which activates port pin P0.3 and P0.5, and it is getting connected to the match signal. Let us see the pin cell registers content. So pin cell registers content I am making 880. So here this is 8, so P0.5, so the 1 and 0. So the 11th bit I am making it as 1, and 10th bit I am making it as 0. So match 0.1. So 0.1 is timer 0, match registers 1. So that is getting connected to P0.5, and this is P0.3. So in case if you want to look in terms of bit pattern, so I will be making this as 1. So this will become 8. So 880. So you can see over here how the bit pattern works. 880, so that the P0.3 and P0.5 is connected with match register 0 and match register 1 respectively. So T0C TCR I am moving the value of 0x0 so that my timer works in the timer mode, and T0 PR I am moving a value BB7, so that is for 1 millisecond. So T0 MCR, so in which I am moving a value 2, so that reset on MR0 occurs. So I am not going to reset MR0 and MR1. So only T0 MR0 when it reaches the value of the T0 TC, T0 TC contents reaches the value of T0 MR0, the reset will occur. So that is there. Okay, so T0 MCR I am making it 2, so that MR0 when the content of T0 TC reaches the T0 MR0 value, reset occurs. And T0 MR0 I am moving a content 9, so that 10 millisecond is given as the delay timing. So T0 MR1 I am moving it with a value of 4, so that 5 millisecond delay will be there. So as far as this match registers are concerned, whatever the millisecond that you need, you will have to give one less than that. So 10 means 9 and 5 means 4. Then so T0 EMR in external match register I am moving the value F and 3. So F, if I put 4 bits will be 1, so 7, 6, 5 and 4 is made active. So this is to make the pin toggle when match occurs, and 3 is for activating external match 0 and match 1. So so we can see the format of T0 EMR. So this is T0 EMR. We are going to activate EM0 and EM1. So this will give 3. And external match, so I need to toggle both the things, so I am making 1 1 1 1, so it becomes F. So in case if you want to see it in terms of bit pattern, we can see it using this T0 EMR. So here what I'm doing is I'm activating these two, so the value has become as 3. So EMC0 also I need to toggle, and EMC1 also I want to toggle. So the total content becomes F3. So you can see T0 EMR is moved with the content of F3, so that both your T0 MR0 and MR1 is connected with toggle option, and T0 TCR is moved with the value of 2, so that your timer is reset, and T0 TCR is moved with the value of 1, so that your timer has been started. So in this case, one thing we'll have to understand, when the timer is running, so only with the T0 MR0 the reset is happening. So this in 5 millisecond it will toggle. So initially after 5 millisecond it will go to 0, and before the next 5 millisecond happens, this 10 millisecond gets over and it is getting resetted. So at that condition, so this toggling will not happen. So this MR1 5 millisecond whatever we are putting over here will exceed the value, so you will get it as 10 millisecond over here, but there will be a phase delay of exactly 90 degrees. So let us see how things are happening. So in this case we need to make 2 ports. So port 0.3 I have made, then port 0.5. So 2 port pins I am using, and let me run the program. You can see now so here the PC is running, and you can see your both your EMC0 and EMC1 is in the toggle operation. So external match, when it is occurring, you can see the content getting toggled. So here let me stop it and let me check it. So here on the time delay, this is P0.3, so I am getting 10 millisecond. So in case if you want to see the P0.5, you can see it is also 10 millisecond, but we have specified 5, we have specified 4 inside the T0 MR1, but we are getting 10 millisecond. This is because, as I've already mentioned, when this one is if you see the initial part of P0.5, we will understand. So both have started, and you can see at 5 millisecond this is getting toggled. So when it is toggling, you can see that this is going to 0, and after 5 millisecond when this is reached, so when P0.3 is toggling, before it is getting toggled, it is getting resetted. So when it is getting resetted, the value of this is 0.5, 0.5, that has been connected with match 1 register, that also is all the values are resetted. So obviously it will start from 0 again. So toggling doesn't occur over here, so but it is supposed to occur over here. So this will occur only when you make the MR1 to get reset. So but we haven't specified MR1 to reset, but MR0 we have specified it to go for resetting. So that's the reason. We are getting this 10 millisecond instead of 5 millisecond. So this particular operation can be used in case if we require specific triggering pulses wherein there should be a 90-degree phase delay. So this is the explanation for the program. And in case we want to get the hardware, same, go into output and click this create X file and run the code again, translate, build and rebuild. Then we have to check the output from P0.3 and 0.5. So P0.3, as we have already seen, it is P0_A3. so P0.5 will be P0_A5. here you can see mat 0.1, mat 0.0. so P0_A5. P0_A5, you can see 13th pin, right? So in J2, 13th I can connect, and maybe second pin I can connect for ground. So 13th and 2nd, and P0A3, that is 10th and 9th. So this is the access point for the two outputs that I have obtained. So this is for hardware. So then coming to the next program, wherein if I want to give some input, so I am taking the next program. So here in this program, what I have done is I am making this I am having, in previous cases the program will be ending with a done and be done, so that there will not be any checking or any changing in the inside the program. But in this case, what I am planning to do is I am going to change the pattern of output. So here the pattern change is like frequency I will change. So basically I'll be using port 1 as the input port and port 0 as the output port, port 0.3 as the output port pin. So when I give some value inside port 1, the frequency should change. So in this case I'm making it like initially the frequency should be 100 Hertz, and when I give a value of 80000000 inside the port 1, my frequency should change to 50 Hertz. So that is my aim or algorithm, you can see. So here in this case I need to declare this IO1 DAR, but IO0 DAR, this is not required. You can remove. IO1 is required. So IO1, this is for setting the input port, and IO1 pin, that I'll be reading the port pin so that I can use it for doing checking, using it for the checking process. And T0C TCR, T0PR, T0TCR, T0TC. so T0C TCR, that is for specifying the mode of operation. T0PR prescale register, and T0TCR, the timer counter for starting and resetting. T0TC, the timer counter, that is for in case if you want to read the content of T0TC. And T0MCR, match control register. T0MR0, T0EMR, and pencil 0. So here IO1 DAR, I am making it as 0x0, so that your port 1 will behave as a input port, and in pencil 0 I am activating 0x80, so that my port pin P0.3 is connected to match 0.0, and T0C TCR I am moving a value of 0x0, so that the timer 0 behaves as a in timer mode. And T0PR I am moving a value B7, so that 1 millisecond is designed for the prescale register. Then T0 MCR match control register, I am making it as 2, so that reset on MR0 happens, and T0 MR0 I am putting a value of 4, and T0 EMR I am making it as 3 and 1, so 3 is for bit 4 and 5, which is to make the pin toggle, and 1 is for activating the match register 0, and T0 TCR2 for resetting, and T0 TCR1 for starting the timer. And now I am getting into the input pattern. So here first I am moving the value 0x0 so to IO1 pin, so that the value, any value previously available, will be getting cleared. So after that I am reading the value from IO1 pin, and I am moving a value of R3 with 800000, so that it can be used for comparing it with the whatever the value that has been read. So R3 and R2 is being compared. So if both the values are equal, then T0 MR0 is moved with the value of 9. So initially it was 5, so 5 millisecond was the delay, and in case if the port 1 is 800000, my output will have a frequency of 50 Hertz, that is 10 millisecond delay will be there. So here in this case it will be 10. So this will happen again and again and again. So let us check the program running. Here I can remove this one. So only port 0.3 is required, and peripherals I'll use GPIO slow interface port 1. Okay, now I'll run the program. Okay, now the program is being run, and let us check the frequency. Time delay is 5 millisecond. Yeah, yeah, 5 millisecond. So let me check after giving the input. So here I am supposed to give 80000. So to do that I am clearing all the ticks over here. So now you can see the thing has changed. So I'll stop and see the output. So 10 millisecond. So 10 millisecond is there, and this is 5 millisecond. You can see you can see the change in pattern that is occurring. So up to here it is 100 Hertz, and when I've given the input value as 800, the frequency has changed to 50 Hertz. So this you can observe from this one. So this is for in case if you want to change the frequency while the program is running, using one port as a input port. So in case if you want to check this one also, we'll run it again. So here whatever the value MR0 is stored with the value 9, you can see over here. So even if you make it again with some other data also, the value of MR0 is not going to change, because we have written the program in such a way like once the data has been changed, that's it. So we need to reset it to make the program to run in the older value. So I am resetting it. You can see MR0 has changed to 4. So again it is running in 100 Hertz. In case if I want to make it again to 50 Hertz, so you can observe this. Please observe this MR0. So you can see now once the value has been changed, this changed to 80000, your MR0 is changed to a value of 9. So when it is changed, this is the frequency is being changed. This is the explanation for this timer match register. Next is we'll look into how to dump the code for the timer match register into the processor. Start.
Sir.
Okay. So this is the Flash Magic. In the Flash Magic, we'll be dumping the hex file that has been generated, and you'll be doing this in advanced options, hardware config. These two should be checked, and T1 and T2 should be 100 and 200 respectively. Then timeout should be checked. This use my timeout should be checked. Then click OK. So COM port is COM1, baud rate 9600, and your oscillator is 12.0, and erase all flash code should be there, and verify after programming should be done. Now I have connected the RS-232, and now I am clicking the start button. So now the code is getting dumped. Okay, so the code is dumped. So I am removing the RS-232, and I am connecting the probe between 10th and 9th. In this case, you can see 10th is P0 A3, and the 9th is the ground. 10th and 9th I am connecting, and you can see over here the pulses that has been generated, which is having a time of 2.5 millisecond per box, so it is 5 millisecond. With 5 millisecond delay, I have created the triggering pulse. Okay. So this is for single output waveform that has been generated. Now let us check for double waveform. Double waveform. So now I am removing the timer match.asm. Then I am connecting this timer match at close. So this one I am translating, building and rebuilding, and so here the hex file is got created. The same hex file I am dumping into the processor using the RS-232. And I am clicking start. So the program is dumped. Okay, so now in this case I'm going to take the pin out from the 13th pin, that is P0A5, and second pin, that is the ground. So let me connect the 13th pin. 10, 11, 12 and 13. Second as ground. Now you can see the two different waveforms that has been generated. Both the waveforms is having 10 millisecond delay. So you can see 5 millisecond for a box. So both comprises 10 millisecond. So you can see the first, the third pin, whatever it is generating is starting from, assuming that it is starting from 0. This second waveform is having a phase delay of exactly 90 degrees. You can see. So 5 millisecond delay is there between the first waveform and the second waveform. So this is the explanation for this particular experiment. Thank you. Thank you.